What's up guys, and welcome to this new video about building a clean architecture wallet application. First, this video won't be about building fancy UI, and also the application will be small. We don't have any database connection and making network calls or something like this. It's mainly focused on validating our business logic with unit tests. And the package structure which we apply and also the different classes will follow the clean architecture principle, and we will validate our use cases which represent our business logic. Let me quickly show you what we will build. When I click on this plus sign, then we can make a deposit. And currently the confirm button is disabled, but when I enter 5 for €5, then we can press confirm. If I append a dot, then the confirm button is disabled again because this is not a valid input. And then we can append a 10, for example, for €5 and 10 cents. Then we can press confirm again. But if I append another number, then this does not make sense for a valid input for a deposit. Then the confirm button gets disabled again. And in this case, a use case checks in the background if we have currently a valid input, and we will validate this use case to work properly with unit tests. When I click on confirm, then we have a deposit, and also the date with the time is shown in this UI item. We can also make a withdraw, for example, €10. And now you can see that when we just enter 10, then 2 zeros get append at the back. And we will also validate that this works properly with unit tests. And at the top, we have the total amount of our wallet, and we will also write unit tests to validate that this use case, which calculates the total amount, works properly. Alright, okay, I'm in an empty Jetpack Compose project. In case you use XML for your layouts, you should be also good to follow along. You only need to build your UI in a different way, but the use cases, the unit tests, and also the view model will remain almost the same. Just the view model, we use compose state here. You need to use live data then when you use XML, for example. Let's go to our build.Cradle. We have two additional dependencies. On the one hand, the material icons extended dependency for the minus icon. I think this is not in the default icons. And we use the Google Truth library for our unit test assertions. And I also added some colors here. This colors can be also found in my GitHub's repository, which is linked down below, but I think we don't need all of them. We only need this orange, gray, and white, and also green and red, orange. But you can, of course, also use your own colors. Let's start with our transaction value input use case, which validates if the current amount is actually a valid input. Let's close this color and build.Cradle file. Then we can go to our root package and create another package called domain. This domain package represents the domain layer. In terms of clean architecture, we always have domain, presentation, and data layer. And this input validation is, of course, business logic, which belongs to the domain layer. In the domain layer, we can create another package called use case. Of course, in this small application, such a package structure is maybe a little bit overkill, but I will strictly follow the clean architecture principles here when it comes to a package structure. In this use case package, we can create a Kotlin class called parse transactional value input use case. Let's also refactor this typo. This is called transaction, of course. Then we can define the operator function invoke. It will take a value of type string, which is the current input, and it will return a boolean whether this input is valid or not. First, we need the decimal point format, which we get from decimal format symbols .getInstance.decimal separator. Because in my country, Germany, for example, we have a different decimal separator than in the US. Then we have our first regular expression, which kind of describes an input format. We can say, well, regex for regular expression, for null, because we need to consider null inputs. So when the user types in 0 or 0.0 or 0.00 in a little bit different way than the other inputs. And this can be described with this string. We have 0 plus, which means we have 1 0 or multiple zeros, but it's not allowed to have 0 zeros. Then after the user types in one or multiple zeros, he can also type in a decimal point format, so a dot or a comma, depending on the locale. And this decimal point format is of type optional because the user does not need to type this in. And then after this, the user has again the possibility to type in a 0 times up to 2 times. So with this regular expression, we can make something like this, 0.0 or also 0.00 and also 0.0, and this will cover all these inputs here. And if this is the case, then we wanna return false because 0 and also 0.00 is not a valid input. We can't deposit €0 or also withdraw €0. And we can then say if value dot matches regex, and we will pass our regex for null. If this is true, then we have the case that user puts in 0, then we can return false. After that, we need to take care of our regular expression, which describes an actual amount. We can call this val regex general is equal to 0 to 9. That means that we have the possibility to type in all values from 0 to 9, and we will append an asterisk which says that this here can happen 0 times up to infinitely times. And after that, we will have a decimal point format again of type optional because the user is also allowed to input something like 5 without a decimal separator. And then if he actually inserted a decimal point format, we will have again the possibility to insert 0 to 9, but only 1 up to 2 times, because if the user actually uses a decimal separator, then he should be only allowed to put in 2 additional numbers from 0 to 9. Maybe you're asking yourself, is this actually true? Is this also actually true? Does this cover all the different valid inputs and also exclude all the invalid inputs? I'm not 100% sure either. I wrote this regular expression when I prepared this video in about 2 minutes. Then I also wrote some test cases. They all passed, so fine. But in production mode, I would maybe also add additional test cases. And then if you detect an error, then you can change this regular expression and you still have your test cases, which are fine, which actually passed. And then you can execute them all again and still validate that this is working correct and also covers your new found error. And this is such a cool thing about test cases. Once they are created and passed, they will always remain the same, and they help you to be sure that you don't mess things up if you make some changes in your code. Okay, all right. After that, we can say return value.matches regex, and we will pass our regex general. And now it's time to write the test cases for this function. For that, we can right-click on this class and click on generate, and then click on test. And the testing library will be JUnit4. And then we can press OK. And this will be generated in the unit test module. This is also fine. We can click OK. And now you can see when we go to our package structure, then we have here under test our same structure than we have in our root package here. And it's also recommended to use the same package structure like you have in your production code. Here we have the root package, the domain package, and in here the use case package and our transaction value input use case test. And then we can open the curly braces, and first we need our use case. We can say private var transaction value input use case is equal to parse transaction value input use case, because this is the use case we want to test. Below that, we can define our first test function. We need to annotate this with @test, and then we can say function test0 without comma returns false, for example. So you should always name your test functions so that you can understand what's actually tested. and then we can say val result is equal to transaction value input use case, and we just pass a 0. And after that, we will say assert that, and we don't want to use the JUnit assert, we want to use the assert that from our Google Truth library. We want to assert that our result is false because 0 is not a valid input, and we expect this result to be false, and we want to test this if this is actually true. Then we can click on run, and the test case passes, so everything works as expected. If we, for example, say is true, then we can run it again, and then you can see that this test case fails. It's expected to be true, but this is not the case because our result is false. For the next test case, we can just copy and paste it down below, and this time we want to test 0 with comma returns false as well. So we will change the input, this time 0,00, because in my case, in Germany, we use this as a comma separator and not a dot. And then we can also check this test case if it's actually true, and this is the case. We can also launch all test cases by clicking on this run above on the class, and then you can see that both test cases actually passed. The next thing I want to validate is if we have multiple zeros before the comma, test multiple 0 with comma returns false. So we can, for example, make 3 zeros before the comma and check on this one, and it also passes, so everything works perfectly fine with this test case as well. And now we can also check if we have a valid number, for example, with 0 before the comma. We can again copy and paste this. You will face a lot of copy and pasting when it comes to unit tests, but also be careful when copy and pasting. There are also a lot of potential issues if you don't adjust things right, so always be careful there. And this test case, we want to say test 0 before comma and value after comma returns true. So this function names are very long sometimes, but I think they should be also named the way what we actually testing. In this case, we want to say 0, 20, and this time we want to assert that this is true, so that this works because 0, 20 is a valid input. Then we can click on run again and check if everything works, and also this test case passes. For the next test cases, I will just copy and paste some functions. You can find them in my GitHub's repository, or also try to write your own test cases. Let's go quickly over them. Here we will check if this is valid, and also if a single number without a comma is valid, and a single number which is not 0 with a comma value but not 2 comma values is valid. These are all valid inputs, and this is again an invalid input because here we have 3 numbers after the comma. This should be false then, and we check this. And also we will check a value which isn't actually a value with this letter. And the last thing we want to test here, if this is actually a valid input, and this should also result in true. And after that, we can click on run and run all test cases and check if they all pass. And this is the case. And as I already said, maybe the regular expressioner does not work 100% right. I'm not quite sure because we only have this test cases. They all pass, but maybe we don't cover all possibilities. Let's assume that we find a test case which actually should pass, but it does not. Then we detect an error. Let's assume that this error is in here, and we just change this value to 1 instead of 0. And now maybe our detected error is fixed, but we still want to be sure that all the logic which worked so far still works. Let's go to our test cases back and run them again. And we can check then, oh, okay, this test case does not pass anymore, this also does not pass anymore, and also this does not pass anymore. So we maybe fixed our detected error, but we changed this code to 0, from 0 to 1, and now all the old logic or some of the old logic does not work anymore. And this makes test cases so powerful. I will change this back to 0. and then we can run it again and see that everything passes again. But this makes test cases so powerful because you can always rely that once they have passed and you change some code, then you can rely on them if your old logic which worked so far still works. Okay, alright, I will leave this for now and assume that our use case works properly. As I already said, maybe you will find a test case which does not pass. Then you can try to fix it and you still have all your old test cases and can validate that they still pass just by running them. Let's go back to our logic. In our root package domain use case, we will have another use case which we also want to test. Let's create a new Kotlin class, and this use case will calculate our wallet amount, our total wallet amount. We have, for example, 5 deposits and 3 withdrawals, and then this use case makes sure to calculate all the different numbers together and will result in a total value. We can call this calculate list sum use case. And we also define the operator function here. Operator function invoke. This will take a list of type list float, and it will return a single float. Then we can say var result is equal to 0f for lm in list result plus equal lm. And after that, we can return the result. Of course, this use case is really simple. It just sums up all the different array values. But maybe in a real-world application, you also need to calculate from arrays elements, and this array is more complex. Then you should, of course, make this a use case. And you can also validate its functionality with test cases then. For that, we go to generate again, click on test, JUnit4 again is fine, click on OK in the unit test module, and then you can see that Android Studio takes care to create the right test classes under the right folder. There's nothing new here. We again have our test functions. I will just copy and paste them here. And in this case, we will have the assert library or the truth library from Google again. Let's make sure to import the right one, and let's go quickly over them. We have our use case which we want to test, and first we want to test it for an empty list. So an empty list should result in 0, and also one element in a list should result, of course, in this one element's value. And here we test the list with multiple values if it gets summed up the right way. And also if we have some elements which result in a negative number, we also validate that everything works with this test case. Then we can click on run and check if everything works. All 4 test cases pass. I think this is enough here for just sum up some values, but maybe you want to apply additional test cases, but I think they are enough here to validate this use case's functionality. One thing I also want to mention is if you test more complex classes, for example ViewModels, which contains state values, and then you execute one test case, for example, and this state values get modified or they change, then they are not initialized here anymore or in the initialized state. And for that, you can also apply such a function, which you can annotate with @before. And we will call this function setup. And this setup function will always be called before each test case. So we could say something like calculate list sum use case is equal to calculate list sum use case. And of course, this gets some compiler error because this needs to be a var then. But now we make sure that this use case always gets initialized before each test gets executed. And for this use case, this does not make sense because this use case does not have any properties. It only contains its function, and we only invoke this function, which does not contain any state. But in case you test view models or something like this, then make sure you use such a setup function to always initialize the view model and provide the initialized state. And there's also a function called after, which should, or in some cases, you need to also do some cleanup work. And this after function always gets called after one test case gets actually executed. The next function we want to define and also validate with unit tests is an extension function for the float class. Because later the user can put in 5, for example, which is a floating value, but we always want to append 2 zeros then, so that we have, let me quickly show you this, something like this, 5,00, or also if the user types in something like this, then we also want to result in 5,10 and not only 5,1. And for that, we make an extension function, because later we will work with float values, and we can make a float extension function, which we can then easily invoke later. You will see what I mean by this. For that, we will go to our root package, create another package called util. For me, it's more of an utility function, because we extend the already provided class float here. But maybe you have another opinion and you want to put this in the domain layer. For me, it will be the util package. And here we will create a new Kotlin file called float extension. We will say function float.format to price. And we will make this function in a real general way, so that we can later make a lot of test cases. This function will take a locale, so we will make this work for different countries or locales. And we also pass or define another parameter, always use 2 comma digits, because we later can also use this function so that it does not append 2 different zeros, for example, when we have a single value. And this will be of type Boolean and false by default, and the function will return a string. First of all, we will have a val separator is equal to decimal format symbols get instance, and here we will pass the locale, and then we get the decimal separator. Then we have a val value multiplied with 10 power of 2 is equal to this multiplied with 100 dot toInt. And now we can get the value before the comma and the value after the comma in a real convenient way. We will say val value before comma is equal to value multiplied with 10 power 2 divided by 100, and val comma values is equal to value multiplied with 10 power 2 dot absolute value modulo 100. Now we can say return if comma values is not equal to null or 0, or always use 2 comma digits. And then we will say val comma values string is equal to if comma values is equal to 0. Then we will say 0, 0, or else we will use our comma values. And then we will say return values before comma separator and comma values string, and we will also append a euro sign. In the else case, if we have either no comma values, or if we don't want to show 2 comma digits, we will simply return value before comma. Now we can generate our test class again. We will click on test again. JUnit4 is still selected. Click on OK. The destination for the test class is also fine. And now we can see in our test module, we have this util package with our float extension tests. Let's open the curly braces, and again I will copy and paste the test cases, because I think this is not necessary that I type all of them off. Let's import tests and also locale. And again, we don't want to use this assert class. We want to use the one from the Droop library from Google. So the first test case, test float to German format without comma value. Okay, we will pass the locale.German to our format.price function. Here we don't even need a value here, because we have this float and this is an extension function, so we can call it like this. We use the locale.German, and we expect that this here results in 10 euro, because if we have a look at the function definition of format to price, always use 2 comma digits is set to false by default, so it shouldn't append zeros here. The next test case, test float to US format without comma values, and in this case there's nothing different, but we pass a different locale, so we should of course also check different parameter inputs, even though the expected result is the same. The next test is test float to German format with 1 comma value. So if we put in 10.5, for example, we use the locale German, then it should also append a 0 here. This is expected because if we have a look at this value here, this does not look good. We want to append a 0 here, of course. Also the same for US, and this time we have a slight different here with the dot instead of the comma. The next test case is a normal floating value with 2 comma separated values, and here we have again the German version with the comma here. Everything should work like this. We will run this after I went over all the test case. Here we have test float is 0 format to single 0. And if we have 0, this is also interesting case. Locale does not matter here, but we can just use US here. And is equal to 0. And here we have the first test case with our forcing parameter. Test float is 0 with 2 comma values if there is no comma value, but it's forced. So we have a single 0 here, but we will force it to append 2 digits, and we have also the locale.us. So this is the expected result. And here we have also a negative number, and we also check on this. And here we have a single negative number, and again a single negative number down here, the last test case, which does not contain any zeros, but we will force it to append, and the locale is US again. And in case you want to also check this for Germany, then we could copy and paste this, test negative float value and force, blah, blah, blah. And here we will say Germany, just really simple, locale.german, and in this case we should have this result. Let's go up to the class, and we can then click on run and check if everything works. And here we can see that we have 4 different test cases which fail, and this is my bad. I immediately see what's wrong here. We have an expected value of 10 euro, but it is only 10, and this is in the float extension function here, because I just forgot to write the euro sign here. And so again, a cool example why test cases are so important. And here we will go back to our float extension test and click on run again. And then you can see all test cases pass and everything seems to work fine. And again, I'm not 100% sure if the float extension function actually works the right way in each case, if it covers all the possibilities. In case you provide your application for alpha or beta testing and the users detect an error, then you can try to fix this error, go to your float extension function, change this piece of code and provide additional logic maybe to fix the error. And then you can go back to your float extension test and you can check if all the previous logic still works. Okay, all right, this was it for the business logic which we wanted to test. And the rest of the video will be about the composables, the view model, and setting up the UI. And I won't go that detailed over this because this video is more about testing, so the explanation won't be too detailed. Let's go to our root package, and we can also collapse this test module. Go to the root package, create another package called presentation for the presentation layer in terms of clean architecture. And here we will have another package called state. And the first state class we want to define is our transaction UI item. So when we later have a deposit or withdraw transaction, then we have the representation inside this transaction UI item class. Here we will have a val description of type string, val value of type float, val date of type string, and val color of type color. Then we have another state class called transaction dialog state. So when we open the dialog to put in a transaction amount, then we will have different states which we need to consider. we have on the one hand, if the dialog is actually open of type Boolean, which is false by default, a val type of type transaction type, which we need to define, is equal to transactioner type dot deposit by default. This doesn't matter if this is set to deposit or withdraw by default. We can actually also just define this enum class here. We will say enum class transaction type, and here we have deposit and withdraw. And then we have another property, wall is confirm button enabled. This button is only enabled if the input is actually valid, which gets checked by our defined business logic use case. This is false by default, and the current value input of type string, which is an empty string by default. Now we will go to our presentation layer package, create another package for our composable components. We will call this components. And the first component we want to define is our transaction dialog. This will be a file because it's a composable transaction dialog. It will take an onDismiss function, which does not take and does not return anything. The value of the current transaction is of type string provided by a lambda function. Then we have an onValueChange function which takes a string and returns nothing. Then at its description, either if it's a withdraw or a deposit transaction of type string, and an onConfirm function which does not take and does not return anything, and is button enabled, which also gets provided by a lambda function. This lambda function and also this lambda function is because it's a little bit more performant if we provide this with lambda functions instead of, for example, just a plain Boolean value here. The root composable will be a dialog, and in the onDismiss request lambda, we invoke our onDismiss function, and in here we will have a card. This takes an elevation of 5 dp and a modifier, and this modifier will fill the max width. Then we can open this card scope. In here we will have a column which takes a modifier. This modifier will fill the max width again, and we also apply a little padding of 15 dp. The horizontal alignment will be alignment.center horizontally. The vertical arrangement will be arrangement.spaced by 10 dp. Then we can open the column scope, and first we will have an outlined text field. For the value, we will invoke our value lambda function. The onValueChange lambda function takes our onValueChange, and we will provide it. And here don't forget the equal sign. Then we have also a text style, which comes from material theme.typography.body1. Then we will have a label. This label will be of type text and will take the description. Then we have colors, which come from text fields defaults.textFieldColors. Here we have a cursor color, which is orange. The focused indicator color is orange as well, and the focused label color is also orange. The last parameter is the keyboard options, which will be keyboard options, and the keyboard type will be keyboard type.phone, so that we have only numbers. Or can we also use decimal? Or numbers better, I think. Below our text field, we will have a button with an onClick method, and here we will invoke our onConfirmPath method. Then we have colors, which come from button colors, button defaults.button colors. The background color will be set to orange. The content color will be white, and this button also takes a modifier. This modifier will fill the max width, and we also apply a little padding of 10 dp. Let's import this white color as well. Then this button will have a shape. This will be a circle shape, and it is enabled or not enabled depending on what this functional is button enabled returns. Then we can open this button or row scope, and here we will have a simple text. The text will be confirm. We have font size here of 18 sp. It's not very consistent here. Here we have font size 18 sp. And up here we use the body1 material theme.typography, but well, let's not care about this. Then we have a font weight dot bold, and the text align will be set to text align dot center. And this was it for the transaction dialog. Now we can define our transaction item. Let's go to components package and create a new file called transaction item. This will be the item or the deposit or withdraw item which gets listed below each other when we make actually or when we confirm a transaction. Here we will have a composable as well, transaction item. This will take a color of type color, the description of type string, value of type float, date of type string, and also a modifier which will be set to modifier to the default one, not the Java one, the compose UI one. In here we will have a row which takes our past modifier. Let's import row. For the vertical alignment, we will say alignment.center vertically. The horizontal arrangement will be set to arrangement.space between. Then we can open the row scope. We will have a column. This will not take a modifier. We will only have a vertical arrangement, which will be set to arrangement.spaced by 5 dp. And the horizontal alignment will be set to alignment.start. And we also import dp. Then we can open this column scope. Here we will have two texts. On the one hand, the description. Let's import text. The font weight will be set to font weight dot semi-bold. The font size will be set to 18 sp. Let's import sp. Then we can copy this text and paste it down below. Here we will have our date. And the font weight will be set to normal here and the font size to 13 sp. Below this column, we will have another text for the transaction amount. Here we will have value.format to price, again, our already defined function, locale.getDefault, and we will pass true for the always use 2 comma digits parameter to force 2 commas if we have a single value with no comma separation. Then we will have font weight, and the font weight will be set to font weight.bold. The font size will be set to 18 sp, and the color will be set to our past color. And this was it for the transaction item. The last composable component we need to define is our wallet overview. So the rectangle at the top where our current value is actually shown, the total value, and also the plus and minus sign for invoking or opening the dialog for withdraw and deposit. In our components package, we will create a new Kotlin file called wallet overview. And this will be, of course, also a composable wallet overview. And the parameter it takes are mainly lambda functions. We will say value before comma. This is again for performance, but you are also good if you just pass an integer without a lambda function which returns an integer. This shouldn't matter here. Then value after comma. We pass this to integers separately because we want to make the value before the comma bigger and also bold, and the value after the comma will be smaller and not bold. Then we have an onDeposit click function, which does not take and return anything, and on withdraw click function, which also does not take and return anything. And it will also take a modifier, which will be set to the default modifier by default. So this allows us to potentially pass modifiers here. Then we have a row. Let's import row. This row will take our past modifier. The vertical alignment will be alignment.center vertically. The horizontal arrangement will be set to arrangement.space between, so that everything gets pushed to the left and the right. Then we can open this row scope, and first we will have an icon button. Here, this will be the icon button for the withdraw. We have the function on withdraw click, which we invoke here. And in the scope of this icon button, we will define the icon, this will be an image vector. Let's import icon first. Image vector, and we can get this from icons.default.remove. The content description will be withdraw. The tint will be white, and the modifier will be set to modifier.size 32sp dp, and import white. Below this icon button, we will have a row with a vertical alignment, alignment.bottom. The horizontal arrangement will be set to arrangement.spacedby 2dp. Then we can open the row scope. First, we will have a text which shows the value before the comma. So we will say value before comma and invoke this function. The font size will be set to 40sp. The font weight will be set to font weight.bold. And also import sp. This will be the single value before the comma. Then we can copy and paste it down below. And in this case, we will have, I will just hard code this comma. Feel free to use the local comma separator. But yeah, I think I should go quickly over this UI stuff, because otherwise the video would be too long. Here we will have a font size of 24sp, and we won't have a font weight. We also need to apply a little bit of a modifier with an offset to make all the different texts with the different text sizes on the same baseline. There's no default parameter to make sure that this happens, because they have all default font padding, and well, this was just annoying, I think. But with this little workaround, we can make sure that they are on the same line. And we don't need the Java-Lang reflect modifier, the Android Compose one. And we will say offset for the X value, we will say 0dp, but for the Y value, we will say -4 dp, like this. Or not, we need to append this dp after the parentheses. All right, okay, then we can copy this text and paste it down below. And here we will have our values after the comma. So we will say percent 02d.format, and for the parameter we will pass our value after comma. This will make sure that we have always 2 values, even if we have only 5, for example. So it will append a 0 after the 5 then. The text size, the font size remains the same, also the offset. We can copy and paste this again. And down here we will only have the euro sign, like this. And the last thing we need here is our plus for the deposit. We can copy this icon button and paste it below our row. And this time we will have a content description deposit. And here we will have the add icon. And also we need to change the onClick method. We will say on deposit click, and then we have created our wallet overview. All right, okay, now we can create our wallet view model, and after that we can put everything together and the app should be finished then. In our presentation package, we will create a new Kotlin class called wallet view model. This will inherit from ViewModel. And here we need to define some state vars. The first var will be var transaction dialog state by mutable state of. And here we will provide the default implementation of transactional dialog state. Import the get and set value for the delegate. This will be a private set so that we can only modify this var from our view model. Then we have var total amount before comma by mutable state of 0. This will be private set as well. Then we have var total amount after comma by mutable state of 0 as well, and private set as well. Then we will also have a val transaction list is equal to mutable state list of, and the type will be transactional UI item. And here we have a little typo, transactional like this. And we also need to access our use cases. We don't do any dependency injection here. Normally, I would provide these use cases in the constructor of the view model, but since we don't use any dependency injection framework, I will just create them here. Private val parse transactional value input use case is equal to parse transactional value input use case, and also private val calculate list sum use case is equal to our calculate list sum use case. Then we have a function on deposit click. Here we will say transactional dialog state is equal to transaction dialog state dot copy. Is open is equal to true, and for the type we will say transaction type dot deposit. Then we can copy this function and paste it down below and say on withdraw click and change this transaction type to withdraw. The next function will be our on dismiss dialog function. Here we simply say transaction dialog state is equal to transaction dialog state, so we initialize it again. The next public function will be our on transaction value change, which gets invoked each time the user puts in a new character. Here we get access to the new value. And first we need a validation result from our use case. We will say pass transaction value input use case, and we will pass this new value. And then we say transaction dialog state is equal to transaction dialog state dot copy. The current value input is equal to our new value, and the is confirm button enabled will be set to our validation result. So the confirm button will be only enabled if the validation result is actually true. So if we have a valid input. Then we have the last public function on transaction confirm. When the user enters an amount and then it's valid and the confirm button is enabled, then he can click this button and this function gets invoked. We will have a val factor first is equal if transaction dialog state dot type is equal to transaction type dot withdraw. Then we have -1 and else we have 1, because we won't deal with minus and plus signs when the user actually inputs a value. We will make this depending on the transaction type. Then we have a val transaction float value, which is equal to transaction dialog state dot current value input dot to float or null. Right now, this current value input should only contain float values, but we will just double check this when we apply this to float or null function. And here we will say times factor, and if this is actually null, we will simply return and do nothing. Then we will have a val timestamp is equal to system.currentTime millis. Also val date is equal to date, which gets calculated from the timestamp. Then we have a val transaction UI item is equal to transaction UI item. For the description, we will pass depending on the type, withdraw or deposit. If transaction dialog state dot type is equal to transaction type dot withdraw, then we will pass withdraw. And well, let me quickly check if you can actually see this, and else we will apply deposit for the description. And then go to another line, apply a comma here. And well, maybe this should be in a separate line like this. And for the value, we will pass our transaction float value. The date will be date.toString, and the color again depends on the actual type. Here we can copy this if statement. If it's actually withdraw, then we have red, orange, and else we have green. And we can also put this in a separate line. After that, we will say transaction list.add our transaction UI item. Then we will also set the total amount, which will be a private function, which we need to define. And we will say on dismiss dialog. Now we define our private function, set total amount. First, we get the total amount from our use case. We can say is equal to calculate list sum use case. Then we are only interested in the transaction lists elements value. So we can say map it.value. Then we have our total amount here. and then we have a value multiplied with 10 power 2, the same value we had when we defined our float extension. Here we have our total amount multiplied with 100 and say round to int. Then we have the total amount before comma, which is our state integer, is equal to value multiplied with 10 power 2 divided by 100, and our total amount after comma, which is equal to value multiplied with 10 power 2 absolute value modulo 100. This absolute value is required because otherwise also the amount after the comma will be set to negative numbers if we have a total negative number. Alright, okay, then we can go to our main activity and put everything together. Let's go to main activity. We can also move this inside the presentation layer because we will use the main activity for our main screen. Normally I would make this a separate composable, but I think for the sake of simplicity this is fine. Let's put this main activity inside the presentation package, click refactor. Then we also need to change this in the manifest. We need to change it with the package annotation. Can close the manifest again. First, we need access to our ViewModel. This will be a private val. Wallet ViewModel is equal to wallet ViewModel. And again, no dependency injection here. We straight initialize it like this. In a production application, I would use something like Dagger Hilt also for providing view models. Then we can remove this default stuff, also remove the preview and the greeting composable. First of all, we can say window.status bar color is equal to orange.2RGB. Also window.navigation bar color is equal to orange.2RGB for a little bit of styling. Then we have a column. This will take a modifier. Let's import column first. The modifier will be compose one, fill max size. The background will be set to gray. And we also apply a little padding of 16 dp. And then we can open the column scope and import dp. Before I forget it, we also have a vertical arrangement here, arrangement.spaced by 32 dp. Horizontal alignment will be set to alignment.center horizontally. First, we will have our wallet overview. And for the different parameters, we now need to make use of our view model. We will have the value before comma, which comes from our wallet view model dot total amount before comma. Let's also rearrange this a little bit. After that, we also have the value after comma, which comes from our wallet view model dot total amount after comma. Then we have the on deposit click function. Here we will say wallet view model dot on deposit click, and we also have the on withdraw click. Here we will say wallet. Let's go to the right place. Well, shit, like this. Wallet view model dot on withdraw click. Then we will also apply a modifier. We will say modifier is equal to modifier fill max width by 75%. Then we will also have a shadow with 5 dp and rounded corner shape of 15 dp. Let me scroll up a bit. And then we will also have a background, which will be set to orange. And the shape will be also of rounded corner shape, 15 dp. And we will have an aspect ratio of 2f, so that it's more wide than it's actually high. And this was it for our wallet overview. And after that, we will apply a lazy column for our different transaction list items. Below the wallet overview, we will have a lazy column. The vertical arrangement, let's also import this. The vertical arrangement will be set to arrangement.spaced by 10 dp. Then we can open the scope and we will have items which come from our wallet view model dot transaction list. And for each item, let's import these items first. We will have a transaction item, which is the composable we already defined. Let's import this. The color will be set to it.color. The description will be set to it.description. The value will be set to it.value. The date will be set to it.date. And we also pass a modifier. This will fill the max width. The background will be set to white.copy. let's import white first, copy 0.8f, and the rounded corner shape will be 25 dp, and we will also have a little padding of 12 dp. Okay, all right. The only thing that's left is the dialog, which we need to put below this column. So down here we can say if wallet viewModel dot transaction dialog state dot is open. Then we want to show the dialog. Then we can say transaction dialog, and for the different functions we again need to utilize our viewModel. For the onDismiss functional, we say wallet viewModel dot onDismiss dialog. Then we have the value. The value comes from our wallet viewModel dot transaction dialog state dot current value input. Well, I don't care about the formatting here. Yeah. For the on value change, we will have a wallet viewModel dot on transaction value change, and we will pass it. The description comes from wallet viewModel dot transaction dialog state dot type dot toString, and we also have the on confirm function, which will be wallet viewModel dot on transaction confirm, and we also have the on button enabled function. Let's make it like this: on button is button enabled. Here we will say wallet viewModel dot transaction dialog state dot is confirm button enabled. All right, okay, then we are good to go to try this out. Let's launch the application, not the tests. Let's change this to app, and then we can launch the application. Let me put this a little bit more in the middle, and the app starts. It does not crash, so this is good so far. Then we can click on this plus sign, and the confirm button is also disabled. This is fine. We need to put in a valid input, so 5 would be valid, 5.12 would be also valid, and if we append another value, then this confirm button is disabled, so everything works fine so far. Let's click on confirm. Then also the list item gets displayed the right way. Let's also do a withdraw, for example 10, and then it also appends the 2 zeros after the 10, so this also works fine. Let's also put in something like this. This should cut, or this should also work and be passed the right way by null 0.50. This is also fine. And well, let's do another deposit 100.12 and withdraw, for example 91 without zeros. And yeah, I think this works perfectly fine so far. And this was it for this video. I hope you enjoyed it and you could learn something about unit tests. And I hope this UI and ViewModel stuff at the end was not too long. But I think it's always a little bit more easy to watch if you have a little bit more of a practical example and not only use cases where you apply unit tests. In case you want to learn more about building clean architecture applications and also production application and advanced programming stuff, then feel free to subscribe. I will do more videos about it, and I hope we see us in the next video.